Go ahead.
So what we're showing is flexible electronics concepts that's based on our graphene conductive ink. And so what this is it's a unique carbon material that's conductive. We blend it with a polymer and print it graphically to get flexible conductive traces. And you can bend this, crease it, it's water resistant, you can wash and dry it, and it maintains its electrical conductivity. So we have some different examples of what you can do with it. For example, we print keypads. We want to take advantage of the flexibility in clothing and textiles. So we integrate flexible batteries in our printed ink to give you a little display on your charge here. Some other examples of what we do with the ink is anti-theft packaging. The actual package has our conductive ink in between the plies of the cardboard to prevent you from cutting into the package or removing the item without setting off an alarm. Other applications include diagnostic test strips and assay plates, which can be printed at high speed.
And then what's this down here? Some kind of a bag.
So this bag has flexible batteries, which have been enhanced with our graphene in the shoulder strap. And so we want to create all of these new systems where you have seamless power and sensors embedded in your clothing. And if you look on the mannequin, also within the shirt, we have sewn into the pocket graphene-coated film, which we hook up to a cell phone battery with a USB. Just with a small current from a USB, it'll provide even resistive heating.
So this is, it's not some kind of a carbon thing like you see in other heated jackets. This is actually the fabric heating up.
There is a graphene-coated film on the back face here.
Okay.
And so it's simultaneously a heating element and a heat spreader.
And this graphene film is extremely thin.
Right. So this is completely flexible. You wouldn't. It doesn't feel bulky. It's not like wires where you might get hot spots.
And can you wash this many times? It's okay.
Wash and dry. It's non-metallic. It won't corrode.
And when I came by the booth last time, the gentleman was talking about applying this technology to, say, the entire pant leg for thermal capability.
Exactly. It's really just limited by what your power source is, essentially.
And a lot of electric, heated jackets have, levels and on and off. Could you combine this with a thermostat? So you just set the thermostat and it would automatically control the on and off and that sort of thing? Okay. Okay. When is something going to come out to the market? Is this strap here available?
So these are prototypes right now. The conductive ink material is commercial today, and we're working with some sports apparel brands to try and get this in stores by the end of 2014.
Okay. And how do you connect this fabric that's heated to the battery? Is it some kind of a how do you solder something to this?
It's essentially just a crimp connector.
Okay.
And it's something that's just like a permanent mechanical connection.
Interesting. All right. And are you working with any companies to make heated apparel?
Yeah, we're trying to get heaters for mountain climbing, sort of ski apparel.
Okay.
Things.
Can this material be used for like sensors, like for heart rate monitoring or anything like that?
It can. We've looked at using the ink to get people sort of sensor input over a larger area where the flexibility and the low cost of the material is going to enable that. We haven't been able to before.
Based on the 2013 timeline, what's the first product you think is officially going to come out using your technology?
So this anti-theft packaging, which we developed in West Vegas, this is in stores today.
Okay.
And it's used for item level protection of high theft items.
Okay. And what is your company name?
This is VORBECK Materials.
Okay. And how long have you been in business?
We've been in business since 2006. So
wonderful. And thank you so much for your time.